And now before we close out the course, I'd like to explain a little bit about the API gateway pattern in microservices and what our options are for implementing one. The first topic for discussion will be explaining the need for an API gateway. I think that once the need is explained, it will be really clear for you to see exactly what it is and where it fits in. Next, I'll go into Spring Cloud Netflix Zuul and show you how it can be used to easily implement basic routing. And finally, I'll go through your options for implementing caching, resource expansion, and protocol translation. To begin, if you've been keeping up with the labs, the system we've been implementing is shown here, at least the fundamentals of it. We've introduced a lot of concepts to help the services find each other, configure themselves, and update themselves, and call each other in a fault-tolerant way. And the system has become more resilient as we've gone forward. But there are still some assumptions. We've assumed that our network is high speed and secure, and that bandwidth is unlimited and latency is zero. Now, if you think way back to the very beginning of the course, I told you about something called the fallacies of distributed computing. And these basically state that you can't assume a fast, secure network. So we have to make some improvements here. To illustrate the problem another way, think about a case where our individual services would need to be called over the public internet. There are a number of concerns that are immediately apparent. First, we are exposing our internal API over the public internet, and we probably don't want to do that. So we will need to add security, but that will mean our client, which is a web page in this example, will have to authenticate with 5 different servers. And more fundamentally, we have a cross-origin resource sharing issue, which we must address. This is because all browsers have a built-in security precaution which disallows JavaScript calls to domains other than the one from which they originated. Now we can get around this CORS issue, but maybe there's a simpler option. Another fundamental problem is that multiple HTTP calls are made to get each word. We've been doing this through all the labs just to get started, but now we should think about the client's need to get the response back in a jiffy. Now, you may be wondering why we don't simply put our sentence server back in here and have the client call that directly. Well, we certainly could in this simple case, but it brings up another issue. We could have multiple dissimilar clients with different needs. What if some of these services are not relevant for some of the clients? What if our client web page allows the user to choose which parts of speech to include in a sentence? Then my client would need to call the back-end services directly anyway. And what if our other clients like the TV or the game console have different needs? The issue here is the microservices are built to be focused and simple, but the clients have specific needs to assemble the content or use the services in ways that our services should not have to concern themselves with. We need something in between. We need an adapter. We need something built to serve the clients directly by taking care of the various back-end calls on their behalf. And this is exactly where the API gateway fits in. An API gateway provides a server-side back-end that is custom-made for the needs of the client applications. It simplifies their access needs by providing a single point of contact for calling into the back-end microservices. It provides an API customized specifically for what the client needs. It provides a single place in the architecture where security can be applied, at least for authentication purposes. It eliminates the CORS issue because we have only one domain on the back end, at least as far as the client is concerned. We have potentially reduced the number of trips to the back end if we have the gateway consolidate a number of individual back end calls into one call. We have the ability to implement caching in the API gateway if we want to, etc., etc. Now, in this illustration, we have 3 separate API gateways. Some sources will show you that you should have just one, and this is really up to you and depends in large part on how similar or dissimilar your client needs are. If they are 95% identical, then one gateway will be just fine. But in this example, our phones and tablets and TVs and traditional web are all different enough that we've decided to make 3 specific tailored gateways. And we'll create more in the future if other varying clients come into the picture. So the API gateway is built to address the remote client's needs. It's a one-stop shop for the client to access. It serves as a facade to the real API. And just to be clear, it lives on the server side, not the client. It reduces the number of calls, and it can reduce the data carried back in the calls to the client. It can remove data that's not needed. In simple cases, it simply routes to the real back-end services, and that's actually the first thing that I'm going to show you when we talk about Zuul. It can handle caching. It reduces the number of service calls. It can handle protocol translation. Now, what this means is that the back-end microservices might be set up to work with messaging protocols or TCP or some other protocol other than something like HTTP. Well, the API gateway would take care of taking the client's HTTP request, putting it into a message, potentially waiting for a reply message, and returning a response. The client application has no need to deal with any of the messaging API. The API gateway can also optimize calls to the backend API by expanding hyperlinks found within RESTful resources. Many times, if we are following RESTful principles correctly, we're doing something that we call HotEOS. Now, HotEOS stands for Hypertext as the Engine of Application State. And what that means is our microservices send links to related resources. And the idea is it's up to the client to make the determination on whether it wants to follow the links or not. Well, the API gateway can take care of resolving these calls and inlining the response so the client gets just the data it needs with no waste or extra round trips. So the API gateway is a pretty key piece to the microservices architecture, at least from the client's perspective. Now let's see our options for implementing them in Spring, specifically using Zuul from Netflix. Zuul is another part of the Netflix family of open source software. It's battle tested in the video streaming business like the others, and Spring Cloud provides an easy way to use it. Now, if you read the Netflix documentation, Zuul is used for a number of different capabilities that we won't get into here. What I would like to explore is its ability to serve as a router and a load balancer. The routing is going to quickly and easily take care of some of our API gateway needs without too much work. Now, when we say routing, this simply means that the client can make a request that goes to the API gateway, and the gateway will immediately send that request to the real server that's responsible for it. This is also known as a reverse proxy, as we are proxying calls to the various back-end services. It's easy to make your own Zuul server. Just make a boot application with Spring Cloud Starter Zuul. All needed dependencies will be brought in, including Ribbon and Hystrix, which we saw before. We only need one annotation to switch it on, @enable Zuul proxy. And the default behavior is simply this. It registers itself with Eureka along with all of the other clients, which of course implies that it is configured with the URL to Eureka, and it collects all of the client IDs reported by Eureka. The client IDs are used to build URIs to the actual backend services. So in our example, Zuul would collect the service IDs and find one called subject. It would then define a URL mapping to /subject that would call the subject service. The verb service would be encountered, and it would set up a URL mapping to the verb service. Any traffic sent to those URL mappings would be immediately routed to the real service. And since Ribbon is involved here, the calls are automatically load balanced whenever there is more than one back-end service available for a given type. And above that, since Hystrix is involved, each call is made within a Hystrix command, so we get simple circuit breaker behavior. When you start up a Zuul proxy server, and you can take a look at this closely when you do the upcoming exercise, you can see what it is doing behind the scenes. After it registers with Eureka and learns all of the client names, it defines some good old-fashioned Spring MVC handler mappings. What it is saying is that the URL pattern for /article and /verb and the others are mapped to a special controller called the Zuul controller. This controller is provided by the framework, and the logic within it simply turns around and calls the actual Eureka-identified service, although it's load balanced and within a circuit breaker. So to explain this another way, and assuming that the Zuul proxy server is running on localhost 8080, a request for /subject would be routed to wherever the subject service is running. And of course, how does the Zuul proxy server know where it's running? Well, it found that out from Eureka. A request for /verb would be routed to the verb service. A request for /article would go to the article service, and so on. So it is almost zero work to create a Zuul proxy that routes client calls to the actual backend services. What else can we do? Well, one thing we can do is exclude services. We might not want to expose all services known to Eureka to our front end. By default, all Eureka services are available for routing. You might not want to do that. So simply list out which services you want to ignore, and they will be blacklisted. And although I haven't illustrated it here, you can blacklist everything by setting Zuul.ignore services to star. And then you can explicitly whitelist the Eureka client IDs of the ones that you want to provide routing to. You can also provide a prefix using Zuul.prefix. This is a good way to distinguish backend services from any others defined explicitly by the gateway itself. Or you might want the gateway to serve up your web pages, JavaScript, and CSS files as well. You can also adjust the URL for whatever need you might have. So in this illustration, we've added the /API prefix and told Zuul that calls to the verb service should not be forwarded. And we've also decided, for whatever reason, that the URL pattern to access the subject and noun services should be altered from the default to be sentence subject and sentence noun, respectively. So, is Zuul an API gateway? Well, I think at best it is a tool that can be used to create an API gateway. A gateway has some needs that are not directly met by Zuul, and that will require you to do some different work. Zuul doesn't address any needs we might have for caching, and that's the next thing that we're going to look at. Also, protocol translation. The microservices can use a variety of back-end protocols, and the API gateway needs to handle these protocols so the client does not need to. And you can do all of this in Java code, but Zuul doesn't really help you here. Also, if your back-end services are REST-based and you are using HotOS principles to include hyperlinks within them, you typically need to have the gateway perform link resolution so the client doesn't have to make so many calls.